Hello everyone, I hope you all are good and you all are practicing problems. Let us for now do this one. So this is a question of meter bridge as you can see from the diagram. So Rx is the value of resistance which we need to calculate. R is the standard one, the one we know already. And then this is galvanometer, this is the jockey, and upon this AB wire we will slide the jockey until we get the null point. And if we get null point here in the question at a distance x from end A, done hai. For that case, we can write an equation. I mean, suppose here is the null point. In that case, it is a structure of balanced Wheatstone bridge, such that आप देखो इसको A लिया है आपने. This is A, this is B, and let us call it C, and let us call this D. So A, B, C, and this is D. So between A and C, there is this Rx, and between this C and B, there is this R, and between A and D, there is wire of length X. So let us say its resistance is something proportional to X. So let's call it just X. And here it is BD. It has a length of how much? It has a length of L minus X. So its resistance will be proportional to this one. And in this case, here is the galvanometer and there is no deflection in the galvanometer. So it has a simple meaning that Rx divided by resistance of this portion. So rho into length of this portion X by A and will be equal to R divided by rho L minus X by A, right? So this will be the thing, okay? और यहाँ पे rho and A क्या है? Rho is the resistivity of this wire, A is the area of cross section of this wire. यानी कि ये छोटा सा जो cross section है, okay? क्योंकि wire को अगर आप देखो तो cylindrical दिखता है, right? Since this is so thin, we are not able to see the cross section, but it will have some. अब देखो rho A will get cancelled, so we are getting Rx by X is equal to R by L minus X. Now let us come to A. And it is said that in one experiment, known resistance R was taken to be 20 ohm. So R is given here, that is equal to 20 ohm. And balancing length was measured at X equal to this. Now with the device with which we are measuring this length from A till this null point, okay, that has certain certain error. So what is that error thing? I mean, it is given here in the question. Let me track it. Is it written? आप ध्यान से देख लो. Yeah, this is measured using a scale having 1 millimeter as the least count. So if we are measuring it with certain scale which has a least count of 1 millimeter, it means it can inculcate, it can add error maximum up to 1 millimeter. Done it? So in terms of centimeter, if you talk about that, error will be 0.1 centimeter. So in the measurement of length, there will be error of this much. क्योंकि error list count के बराबर ही हम लिखते हैं, maximum that can be the error. So it is this one here. और यहाँ भी देखो x का value is given as 20 plus minus 0.1. So error here is how much? 0.1 in the unit of centimeter. Same as equal to the list count. So यहाँ से आप directly read कर सकते हो error इतना ही होगा. Okay, so what we are asked to calculate? We are asked to calculate Rx. And since Rx here you can see will depend on x and L minus x value, and x and L minus x are getting measured with certain error, there will be error in Rx also. So first of all, we will calculate value of Rx with this expression. Later on, we will try to explore what will be the error getting introduced to Rx. क्योंकि एरर आएगा बिकॉज आर एक्स का वैल्यू ऑफ एक्स और एल माइनस एक्स को मेजर करके ही निकाल रहे हो. सो लेट अस पुट द वैल्यूज फर्स्ट एंड लेट अस कैलकुलेट आर एक्स का एब्सोल्यूट वैल्यू. सो दैट इज इक्वल टू हाउ मच? आर इंटू एक्स बाई एल माइनस एक्स. So if you check it, this is 20 and x is how much? You have already 20, right? So centimeter में ही लिखती हूँ because centimeter will get cancelled. L is 1 meter, right? A standard meter bridge में ये length 1 meter का ही होता है. And in this question also it is given as 100 centimeter, 1 meter. But you should not take always this equal to 1 meter. You should read the question carefully and try to see कि what is the given length of AB. But a standard अगर नहीं दिया हुआ है, you have to take it as 100 centimeter, that is 1 meter. So if this is 20 centimeter, then this will be how much? 80 centimeter. So यहाँ आप put कर दो 80, this, this. So you are getting 5 ohm. Now you cannot write answer as 5 ohm. You should add some error over here. So error आप कैसे निकालोगे? Now we can do this very easily. जैसे देखो Rx is sum of what? R x divided by L minus x. So R, there is no error in the measurement of a standard resistance, right? So that is given to the correct point as 20 ohm. So there is no error in this. Done it? And there is error in x, there is error in L minus x. So basically this is like you are calculating certain quantity y such that y is equal to a by b. There is error in a, there is error in b. So how we add such error? We add their relative error. So यहाँ पे आप लिखोगे delta rx by r is equal to how much? Delta x by x plus now delta L minus x. We should not write because whatever is measurement in the error of x will be measurement in the error of L minus x, right? Because same device we are using for measurement of this length and this length. So that will be also delta x. अगर मैं कह रही हूँ x में error delta x है तो L minus x में भी delta x ही है because both lengths are getting measured by same instrument. So L minus x. अब आप पुट करो इसको I mean, let us put the values. Delta Rx, we don't know. That is what we are trying to calculate. R value, Rx value, we know that is 5. So 5 लिखो आप. Delta X तुम्हारा क्या था? 0.1 centimeter. X was 20 centimeter. Centimeter unit में ही लिख रही हूँ मैं. Delta X again 0.1. This is 80. Let us make the denominator same. So this will become this. And this will become 0.5 by 80. ठीक है, इसको आप 10 ले जाओ. So this will become this and this. So delta Rx is equal to how much? 1 by 32 and that will be close to 0.03 ohm. ठीक है, सो आई मीन अगर आपको Rx की वैल्यू लिखनी है, Rx की वैल्यू यू विल बी राइटिंग एज 5 प्लस माइनस 0.03 ohm. This will be the correct answer. Okay, so for first we have already calculated. Second में क्या कह रहा है? So that fractional error in calculated value of Rx is list when x is equal to this. So we are asked that fractional error, that is delta Rx by Rx, is or you can say this, I mean this error is list when what is that? Okay. Fractional error in the calculated value of Rx is the list when x is equal to L by 2. So we have said that error will be list when x is equal to L by 2. अब देखो हमने जो Rx निकाला, Rx value was this much. Error value you just need to calculate, fractional error, okay? So that is this term. This is the value we had got, right? So इस चीज को फिर से आप लिख लो, delta Rx by Rx is the fractional error and this is equal to delta x by x plus delta x by L minus x. आप इसको solve करो एक बार. This is delta x which is constant, right? This is 0.1 centimeter and this will become L minus x plus x divided by x L minus x. So this is equal to how much? Delta x and this is by into L divided by how much? X L minus x. So fractional error देखो क्या मिल रहा है हमें? Fractional error is this. And in this term, what are the things which are constant? This is constant, right? Always equal to 0.1 centimeter because the list count of instrument is 1 centimeter, 1 millimeter, right? So delta x, error in measurement of length, that is constant. Length of the wire, that is 1 meter. I mean, yeah, that is also constant. X is what? Null point. Again, that we can vary in order to make this fractional error minimum. Okay, so we have to minimize fractional error. And for that case, we need to maximize this value. क्योंकि fractional error हमें क्या दिख रहा है? That is equal to some constant k divided by x L minus x. So this will be minimum is this denominator is the maximum. So try maximizing it. So आपको कौन से function को maximize करना है? X L minus x. So let's say this is function of x like this. You have to maximize it. You will differentiate it. आपके लिए बहुत आसान है ये करना, right? So if you will differentiate it with respect to x, you will be getting x taking constant. First you will differentiate L minus x minus 1 plus L minus x taking constant, differentiate x 1 and first differentiation को आप 0 से equate करो. You are going to get how much? L minus 2x is equal to 0 and x का value is L by 2. We are getting single value of x. for the first differentiation, right? And if we are getting single value, we don't need to do the another check where we will calculate f double dash x. जैसे आप निकाल ही लो, अगर आप निकालते हो फर्स्ट डिफरेंशिएशन हमारा क्या आया, l minus 2x. If you differentiate it for the second time, you will be getting minus 2. Second differentiation is definitely less than 0. So for value where first differentiation was 0, at that value function will be what, maximum. ठीक है. So this function x l minus x is maximum, is max at x is equal to l by 2. So हमारा क्वेश्चन क्या था, क्वेश्चन था कि हमें प्रूफ करना था, राइट? एरर, फ्रैक्शनल एरर कैलकुलेटेड for Rx is least when x equal to L by 2. So yes, it is least when x equal to L by 2. Now the question is, what shall we do to ensure that x is close to L by 2? क्या करना चाहिए हमें x को L by 2 से क्लोज करने के लिए? तो आप ध्यान से देखो इस एक्सप्रेशन को, ठीक है? So Rx by R will be equal to, if x is equal to L by 2, this will become L by 2, then this also will become L by 2, and in that case this will become 1. So we should try to take or pick a standard resistance in such a way that its value is closer to Rx. And to the long, it is, I mean, how much closer it is, that much accuracy will be there in the measurement of Rx. Because fractional error in Rx is least when x is equal to L by 2. And when x is equal to L by 2, Rx closes to R. डन है. सो स्टैंडर्ड रेजिस्टेंस आपको इस तरह से पिक करना होगा जो कि आर एक्स के करीब हो. अब आप कहोगे आर एक्स पता नहीं है तो स्टैंडर्ड रेजिस्टेंस को कैसे पिक करें, सम आइडिया मस्ट बी देयर. आई मीन इफ यू आर कैलकुलेटिंग आर एक्स वैल्यू, some rough idea you must be having, like ki it is closer to certain values, but exact value you don't know, so that is why you are using meter bridge. There is no other option, right? So yeah, that way we can do by making R and Rx closer. So I hope you have understood this question, but if you have any doubt, you can always let me know in the comment section. Thank you. Take care of yourself and keep on solving more number of questions. Bye bye. Take care.